Regression is a powerful statistical method that helps us uncover the relationship between two types of variables. Imagine you want to know how your years of experience might affect your salary, or how the age of a mobile phone impacts its price. Regression provides a way to analyze these connections and make predictions. At its core, regression helps us understand how one thing influences another, making it a fundamental tool in data analysis. By examining patterns in data, regression allows us to make informed decisions and predictions about the future. Let's dive deeper into the main players involved in regression and see how they interact. In regression, there are two main types of variables: the independent variable, also known as the predictor X, and the dependent variable or the target Y. The independent variable is something you can control or use to make predictions, like your years of experience. The dependent variable is the outcome that depends on the independent variable, such as your salary. The relationship between these variables can be positive, where both increase together, like more experience leading to a higher salary, or negative, where one increases as the other decreases, like an older phone losing value. Understanding these relationships is key to making accurate predictions. Linear regression is one of the simplest and most widely used forms of regression. It works by drawing a straight line through your data points to predict future values. The magic formula is y equals mx plus c, where y is what you want to predict, x is what you already know, m is the slope of the line, and c is the intercept. There are two main types: simple linear regression, which uses just one independent variable, and multiple linear regression, which uses several. For example, you might predict a test score based only on study hours or include attendance and previous marks for a more accurate prediction. Linear regression comes with its own set of advantages and disadvantages. On the plus side, it's very easy to understand and use, making it accessible even for beginners. It processes data quickly and is less likely to be confused by random noise in the data, helping you avoid overfitting. However, it does have limitations. Linear regression assumes that the relationship between variables is always a straight line, which isn't always true in real life. It also requires the variables to be independent of each other, which can be a challenge in complex datasets. Knowing these strengths and weaknesses helps you decide when to use linear regression effectively.